Find a third-degree polynomial with leading coefficient of 1 that has zeros 2 and -4 plus I. Since it's a third-degree polynomial and we're only given 2 zeros, we need to first find the third zero. And we know -4 plus I is a zero. Its complex conjugate, -4 minus I, must also be a zero. So if we wanted to write this over the complex numbers, we could call the function f, and to find the factored form, we need to do x minus each zero. So we have x minus 2 times x minus -4 plus I, and then x minus -4 minus I. Now we'll just go through and clean up those last two sets of parentheses. We have x plus 4 minus I and x plus 4 plus I. And we now have the function factored over the complex numbers. If we wanted to write it factored over the real numbers, we need to distribute those last two sets of parentheses to remove the I. So f of x equals x minus 2, and now we'll go through and distribute the x, distribute the 4, and distribute the negative I. Distributing the x, we get x squared plus 4x plus xi. Then distributing the 4, we get 4x plus 16 plus 4i. Finally, distributing the negative I, we get negative xi minus 4i, and then minus I squared. Now we can go through and simplify again. At this point, terms that have an I should go away. xi and minus xi add to 0. 4i and minus 4i add to 0. And then this negative I squared is really -1 or +1. So simplifying once again, we have x squared plus 8x plus 17. And now we have the polynomial factored over the real numbers.